These examples are going to have you find a formula for the trig function, whether it's sine or cosine, identify the midline, the amplitude, any horizontal stretch or compression that may affect the period that's in the graph, and find the b value. This will not include any horizontal shifts, left or right, but you will need to remember the sine and the cosine graphs. So here for the sine graph, if it starts at the midline, the graph starts when the x value is 0. If it starts at the midline and increases, goes up in this fashion, then this is going to be a positive sine graph. Okay, the number out front will be affected by amplitude, but the sign of it will be a positive sine function. If the function starts in the middle at that midline when x is 0 and decreases and the graph itself goes down, then you're going to have a negative sine function. Again, the number of that amplitude will be out front, but the coefficient will become negative because of the shape of the graph. For cosine, cosine graphs either start at a minimum or a maximum. So if you have the graph starting at a maximum when the x value is 0 or the t value or theta, then you have a positive cosine function. And if you have the start of the graph at a minimum when the x value is 0 or t or theta, then you have a negative cosine function. So those are the 4 possible functions that you'll build off of, but it's your job to identify whether they're positive or negative in sine versus cosine. All right, so the first one we have sine or cosine. So it starts in the middle, increases, so it's definitely going to be some variation of the sine of t. Our input variable is t here. So our next job will be to figure out what's the amplitude, what's the b value that's affected by the period, and then if there's any midline shift, we'll add or subtract that to the end. Okay, so for this one, the midline remains at y equals 0, so there is no horizontal or vertical shift up or down here. The amplitude, again, runs from midline to a peak, so either 0 to 4 or 0 down to -4. So our amplitude value is going to be 4. So we have y equals 4 sine of some stretch or compression that's on the horizontal. So you can see from this picture that while the whole thing gives you one, it starts here at 0 at a quarter, like the t value of 0.25. You're a quarter of the way through your curve, and then it's safe to assume that this is like 0.5 halfway through your curve, and it would keep going to the right, but we can look at it to the left as well. And this is actually one complete period, and that runs from -0.5 to +0.5. So the value of the period for it to complete one cycle is 1. And if we use the formula that the period is found by taking 2 pi and dividing it by the absolute value of that b coefficient, if you recall, 2 pi is the period for a normal sine function, but we have to divide it by this factor of b if it gets horizontally stretched or compressed. So I will plug in the period value of 1, and 1 equals 2 pi over b, and then solving for b will give us that b is 2 pi. So 2 pi is the value that goes as the coefficient on t. So our final function is 4 sine of 2 pi t. Next graph, when t equals 0, the graph is starting at a maximum. So that means this is a positive cosine function. So we'll have y equals some variation of the cosine of t. You'll see that your midline is here at 0, so there's no k value to add or subtract to make it shift vertically up and down. Here's 0. The amplitude is defined by midline to a minimum or midline to a maximum. Because you're given that this coordinate point is 2, -3, -3 is the value for the y-coordinate, so +3 would be the symmetrical one up the y-axis, so this graph bounces back and forth between -3 and 3. So the amplitude here has a value of 3, and it's going to be a +3 out front because it was a positive cosine graph. So we have 3 cosine and then some horizontal stretch or compression, the b value that we have to find. So from the graph, we can follow where it starts for one complete cycle and see that it has a period of 4. So using that period is 2 pi over b, we'll have 4 equals 2 pi over b. Again, solving for b makes it 2 pi over 4, which reduces to pi over 2. So that is the coefficient that gets put on t, so that you have your, I guess that would be a compression of the function, because pi over 2 would be a little over 1, so it would be a horizontal compression. But it's 3 cosine pi over 2 times t for your function. Okay. This one has a different midline, so we'll address that when we add or subtract add a value because it's shifted up. This graph starts at a minimum, so whenever t equals 0, there's a minimum. So that's going to make this a negative cosine graph. So we have negative cosine and something on t. The amplitude, so this coordinate point is 3 pi and 2. The y value is 2. So your midline is at y equals 2. So origin up to 2, then it's safe to assume it goes from 2 up to 4. So your amplitude is 2. So that's going to be the coefficient that goes out front, multiplied by the cosine. So we have -2 cosine of some b value times t. Because we had a midline of 2, it's going to bump our graph up +2 on the end. And now we just have to find this b value given the period from our graph. So if we go to our graph where it starts, one full cycle is going to be a period of 4 pi. Here at the middle, this maximum, the t value is 2 pi. So if you double that, you'll get your full period of 4 pi. So the period is 4 pi. Again, we're using that period as 2 pi over b. So 4 pi equals 2 pi over b. Again, solving for b would make it 2 pi over 4 pi. The pi's cancel. You get a b value of 1/2. So your final answer is -2 cosine of 1/2 t plus 2 would give you that graph with those points. All right. The next one we see starts in the middle, works its way up. So this is a positive sine graph. It still has a midline at 0. It's still setting on the x-axis. So this is not going to have any plus or minus values that shifted up at the end. You can see the amplitude is 8/10. So we'll start our function with y equals 0.8 sine of some b variable times theta. Theta is our input, so you have to make sure that you put the right input variable when you give your function. So we'll find our b value given that our graph has a period. Alright, so the pi over 7 is not the period for one cycle. If you notice the graph, when it starts at theta equals 0, it does 1, 2 full cycles to get to pi over 7. So pi over 7 is really the value for 2 periods. And if I wanted to know this theta value, then I would just half the pi over 7 because it would be, it's symmetrical, it's periodic, does the same thing, repeats. So if I do pi over 7 and I half that, multiply it by half, I get pi over 14 is the amount for one period. So if I have the period of pi over 14 and I have period as 2 pi over b, then I have pi over 14 equals 2 pi over b. So b is 2 pi over 14, and dividing by a fraction will multiply the reciprocal. So the pi's cancel, and we get that the b value is 28. So your final answer is 0.8 sine of 28 theta. Next example has a midline at y equals 4,000, noticeable with the dotted line. So we start at the midline and work our way up. So this is a positive sine graph. You can see here that the amplitude is 4,000. So we'll have 4,000, it's positive 4,000 sine of some x value, and then we'll add 4,000 to the end because that's what our midline got bumped up to. Finding our b value using the fact that the period, if we follow it, starting at x equals 0, starts at 0, works its way back up when x is 60. So our period is 60. So we have 60 equals 2 pi over b. So b equals 2 pi over 60, which does reduce to pi over 30. So that's our b value. And we get the equation 4,000 sine of pi over 30x, because x was our input variable, and then add 4,000 on the end. All right. Okay, another one, midline is shifted up to 20. So we'll have a plus 20 on the end. The graph when x equals 0 starts at a maximum. So at x equals 0, there's a maximum. So this is a positive cosine function. And we can follow, let's see, amplitude here from the midline to a peak. Again, 20 down to 10 or 20 up to 30 leaves an amplitude of 10. So we have y equals 10 cosine of some b value to x, and then plus 20. So if the period we identify, again, start it, do one full cycle, it does match an x value of 12, so the period is 12. And using that period as 2 pi over b, we have 12 equals 2 pi over b. B is 2 pi over 12, or pi over 6. So your formula is 10 cosine of pi over 6x plus 20. All right. Another one that's a little bit harder to read graph-wise. It does start at the midline and the graph goes down. So starting at the midline makes it a sine function, and the fact that it decreases makes this a negative sine function. You have the 0.94, so here's 9 on the x-axis, 4 is up here on the y-axis, so you have a maximum at 4. So if it starts here at the origin at 0 and goes up to 4, it's safe to assume that this y value midline is 2, because 2 is in the middle of 0 and 4. So we'll have our negative sine function and then we'll add 2 to bump it up for the midline. And then amplitude-wise, the amplitude is going to be 2, so it's -2 out front. The tricky part here will be coming up with the B value. So for this graph, whenever we start and run one full cycle, you don't exactly have the X value that corresponds with that. What you do have, however, is the X value that corresponds with 3/4 of this, right? Because every concave piece, you know, from 0 to this minimum, that's 1/4 of the period. From the minimum to the midline, that's another 1/4 of the period. From the midline to the maximum, again, another 1/4 of the period. And then maximum back down to the midline completes the last 1/4 of the period. So the X value of 9 is representing 3/4 of a period. So if 3/4 of a period is 9, you can use that setup to determine that one period is actually going to be 12. If I multiply both sides by 4/3, I get 36/3, so the period is 12. So I'll find my B value using a period of 12, and that period equals 2 pi over B. So 12 equals 2 pi over B. B is 2 pi over 12, or pi over 6 reduced. And that's your formula. -2 sine of pi over 6 theta plus 2. A little bit harder when you had to come up with when the whole full period wasn't given, but you were given 3/4 of it. So you could come up with the whole thing. And final one here, we have a graph starting at a minimum, and it's increasing, so this is a positive cosine graph. We have it going from, let's see, we have the midline identified at 3, so if it starts at the origin and goes to 3, then that maximum Y value will also go up 3 more to 6, so our amplitude is 3. And again, go back to starting at the minimum and increasing. That's actually going to be a negative cosine function. So y equals -3 cosine of some number with beta or theta, and then we'll do +3 to bump up our midline. So for this one full cycle is shown, but you're only given the value halfway through it. So if the maximum occurs at 2, it's safe because it's symmetrical, then the period will continue to be at 4. So if the period is 4, then we can come up with the B value to put in our equation. So we have 4 equals 2 pi over B. So B equals 2 pi over 4, which is pi over 2. And then we'll put that in for our value of B. So we have -3 cosine of pi over 2 theta plus 3 for our final equation.